and then I'll hit the record button and I'll do an introduction. And then I'll hit the record button. Okay, we're now live on YouTube, so we've got them going. Welcome to anyone who joins us there. No one's in there yet, but perhaps they will now it's popped up. Right, I'm going to hit the record button, and Rick, I'll introduce you, and then I'll hand the microphone to you. So let me just... So a very big welcome from Denby Dale Amateur Radio Club to Rick, DJ0IP, coming back for the second part of his presentation on the off-center fed dipole and the associated balance to use with it. Rick gave us a fantastic presentation at the last meeting, looking at the good and the bad things about the off-center fed dipole and the things that he has learned and discovered from all the work he's done on it over the years. And the second part, tonight's part, Rick's intention is to try and help people who want to build one for themselves and give some more concrete information about how to approach the job. So Rick, without any further ado, I'm going to hand the microphone over to you and let you take it away from there.
Okay, I guess I have to hit share my screen.
You do.
If I can find the right one. Share. Can you see it?
Yeah, we can. Yep.
Great. Of course, it's covering. I always have the same problem. The menu is covering the top 10% of my screen. So glad to be back. Thank you guys for coming back again. Sorry it was so boring. Last time it was just technology. Today it's going to be a lot more interesting. There's actually only one slide where we all have to put on our thinking caps, but the rest should be quite interesting. Now, as you see, the title is Do It Yourself, DIY. Now, I have a pretty good friend in England who calls it BIY, and he says that means botch it yourself. And that's exactly what we don't want to do. We want to learn how to do it right the first time and not botch it, you know. And believe me, I botched many of them until I got to where I am today. So, whoops. Now, just to recap on part one is what I'm going to do real quick in the beginning, and then talk about importance of the choice of components. We're going to spend quite a lot of time on the balance because that is the most critical thing. And that's what's wrong with most of the OCFDs that don't work as well as they could. We'll then look at, choosing the feed point positions. I have my favorites, but that doesn't mean that they're going to be the favorites for others, We're going to talk about overall lengths and wire and the effect of the size of wire that has on selecting lengths. And then one more time, tuning the antenna. And at the end, I've got a couple of tips on the OCFD antenna, just two. And I should go back. Of course, once again, there's a page on my web page dedicated to commentary and backup material, support material for this part of the presentation. It's a different page than it was last time, but you can follow the link here or at the end of the presentation. First of all, the recap, as you recall, it was a half-wave antenna. Balun inserted somewhere between the middle and the end. Not quite a harmonic antenna. You have to carefully choose where you place minimum SWR on the fundamental frequency or fundamental band. It has to be below the band. Otherwise, it will be above the bands on the harmonic bands. Okay, critical in construction. If you use the wrong balun, the wrong feed point, the wrong material, this can ruin the antenna. Not necessarily ruin it, but it might cause maybe one band not to work or something like that, or high SWR. As I said, the balun is the most critical component. And in my opinion, there is no ideal balun currently available on the market. I know too that sometimes work, under certain conditions they don't work. And I know a new startup company that some friends of mine have started in the States, and I've been working with them, and I'm hoping they're going to start offering kits to build it like I want to do it, So an RF choke is almost always required, and it's better to say it's always required because it's extremely rare that you don't need an additional RF choke, as shown up here in the picture at the top of the page. Insufficient balun and choke results in detuning the antenna. Tuning is critical, and we tune the antenna not by adjusting 80 meter or if it's a 40 meter OCFD, not by 40. We tune it always by looking at 15 and 20 meters and settling on the best compromise for those two bands. So the importance of components, well, like I said, the choice of the balun design is important, but the ferrite mix, the turns count, the number of turns, the type of transmission line, all of these are critical. And when I build a 40 meter OCFD or an 80 meter OCFD, I don't use the same balun in both. They're different. It's the same cores, but I have different turns counts. Most of the common commercial baluns we see, they don't even consider that. That's why I see them advertising in the baluns. They're an OCF balun, and they go from 160 meters to 6 meters, DC to daylight. But is that really what an OCFD needs? And the short answer is absolutely not. So my recommendation is to do it yourself. And I'm going to show you just how easy it is. And I wonder why I have a capital Y there. Oh, well, every time I go through the presentation, I find a spelling mistake or something like that. So, okay, antenna wire must be either copper weld or hard drawn copper. Soft drawn copper, it's okay maybe for a day outing and probably with a 40 meter OCFD. But if you have an 80 meter OCFD, after about a year, you're going to find that the SWR has moved on all the bands because the wire has stretched quite a bit. Weatherproofing is important, but the balun need not be built into an enclosure. And actually trying to find an enclosure and get all the bits and pieces into it is one of the most difficult parts of building a balun. So it can be built onto a plexiglass or an epoxy board. FR4 is the name for that backplane. That's like printed circuit board, but out of epoxy, but without the copper on it. Critical connections like solder joints must be sealed with heat shrink tubing, liquid electrical tape, or silicone. And I'll show you some of this stuff later when I switch cameras. So now, which balun? This is a bit that confuses just about everybody, and I'll sit back and let it build by itself. These are the choices that we have: voltage, current, Guanella, Rutherford, Maxwell, hybrid, 1-to-1, 2-to-1, 4-to-1, anything to one. Should we use coax, bifiller, twisted pair, enamel, insulated wire, Teflon insulated wire, which toroid, what mix, how many turns of wire, should we use an enclosure or not? All those things need to be considered. And it's no wonder people are kind of lost. And it's no wonder we see so many different recommendations about what you ought to use and so forth. So what are the requirements? And this is the part that I think most people, most of the balun vendors, but even the people building things don't quite understand. So which type of antenna, if we want to build a balun, which type of antenna, which frequency should it cover? How much power? And by the way, are you going to run digi? Because if you run digi, the balun can only handle about 1/3 as much power in digi as it can on the SSB and CW modes. What's the common mode current behavior of the antenna? That's very important. The same thing is the common mode current on the antenna, or it's actually from the antenna applied to the feed line. Is it the same across the entire spectrum? Does it peak at the low end of the spectrum? Does it peak at the high end of the spectrum? And here's a good one. What level of common mode current causes problems? In chats in Facebook groups with WHAI, Tom Rauch, he said you can never, ever get rid of all of the common mode current. There's always a little bit there, but below a certain level, it doesn't matter because it doesn't have any negative effects. And in my opinion, you have to know and understand all of this before you even begin to build your balun. And if you don't do that, you might as well get this guy to build it for you. And sometimes looking at some of the products offered on the market, I think that's who designed the baluns for them. Now, I assume I need to change my camera just a second because I want to show you something. And it doesn't want to let me change my camera. Well, I can't change the camera, so I probably can't show you. if I hold this up, yeah, abracadabra, you're not going to see it. Okay, I'll just read it. This is called a engineering design process. And anytime and I probably several of you are engineers, or well, actually looking at you, I'd say were engineers when you were at a job. Now that we're retired, we're not. So, but you begin by defining a problem. Then you do background research, you specify requirements, and then you brainstorm. You brainstorm and evaluate and choose a solution, then you develop and test and go back and modify. It seems to me that the balun vendors are all forgetting the first few things. That they're not doing any background research on the antenna. They're just starting by building what they think might be a balun, And how do they know? Well, they read something in Civic, and that's all there is to it. So that's just not the way you have to do it. You got to define your problem. Okay, there we go. So the reason I go up and down is I've got to read it myself, and it hides behind the menu. So this basically said what I said before. We have to understand the common mode current characteristics of the OCFT antenna. Now, this is the only slide that's it's very busy, and put on your thinking caps. We'll just go through it briefly, but I want you to at least see the amount of work I put into understanding the antenna before I define the balance. In 2013, actually in 2012, the whole winter long, I planned this operation. I worked closely with G3TXQ, who's unfortunately a silent key now, G3UNA, David, some of you may know, and a few others helped with it. And the idea was to take a 40-meter OCFD, but also a 40-meter dipole, and run a bunch of tests. I began with the dipole so that I'd have a stake in the ground to see how that was, and then go with the 40-meter OCFD. And then I had, what I'm showing on this page is about 1/4 of all the tests I did. It shows a single core 4-to-1 Guanella current balun, and on the right, a dual core 4-to-1 Guanella balun. And then on each one, I had 4 tests, but I did the 4 tests across 4 different bands, 40, 20, 15, and 10. I began with 12 meters of coax. Why? I had a 12-meter spider beam fiberglass pole. The antenna was comfortable at 11 meters height. So I needed it to get to the ground and have about a meter to a table. And I thought, okay, that's a typical length. Nothing particular, just convenient. And speaking with Steve Hunt, G3TXQ, he taught me that the worst common mode current is at the feed point, and that repeats every half wavelength down the coax. And it's basically physical half wavelength, not electrical. But it's least at a quarter wavelength. So that's in this green box here. That would be about 49.4 feet. So I started with my 12 meters of coax, and I had a piece 8 feet long, which just coincidentally, that took me to 47.4. That was close enough. And I had pretty low values here compared to some of the others we'll look at. Worst case is a half wavelength. So I found if I added 25 feet to the 12 meters, that gave me within 1 foot of being the worst case. But the very, very worst case, and I showed this in the last presentation, when I would take the coax and bend it way over, near either end. I actually tried this in both directions, and had it bent much more radical than what it's even shown in this little picture down here. So I ended up with altogether 64 common mode current tests, but I also did 64 scans of the SWR because I wanted to visualize the influence that the common mode current had on the curves, right? And of course, I did that for both balances. It was 256 tests. So let's just have a quick glance at this. And if you look at this, off to the right, it's mostly pretty low values. There was a couple of lengths of coax where you got a little bit of a higher common mode current, but the problem was invariably on the lower band, on the fundamental band. So I don't need a balun from DC to daylight. I need a balun whose main or highest common mode impedance is on the fundamental band. I don't need it to go lower than that. And, I might want to have it up through the third harmonic or something, but perhaps I should state, I determined 30 milliamps of common mode current on the coax caused no noticeable, first of all, I could not see anything in operation, but even looking at the SWR curve, no degrading of the curve. It looked just like a perfect antenna. At about 50 milliamps, you could just barely see, but I was looking for it. You might not have even noticed if you weren't intentionally looking for it and comparing to other graphs you already had. So it began to have a little bit of flattening of the curve at 50 milliamperes. So, if we're down here 45, 30, even 60, 70, this isn't going to really harm much. But we saw in the last presentation these 340, 300 milliamps, that can be 50 watts of RF flowing on the outer surface of your coax all the way into the shack. Okay. Like I said, about 1,000 tests were done here. I thought I had figured it out. We had to have a dual core 4-to-1. And what was it Mark Twain said? It's not what you know for sure. No, what you don't know that gets you in trouble. It's what you know for sure that just ain't so. It wasn't that it just ain't so, but it was only so for the 40-meter antenna that I tested with this split. If you have a more radical split, it gets worse. In that case, the 4-to-1 dual core gonella balun, which was pretty much okay. I mean, normally you don't skew your coax like this, so then it was okay. That was okay with this antenna. So 2 years later, I did a battle of the baluns, another field test. I made about 500 measurements here. The idea was to shoot common mode impedance at this. The target was the common mode current from the antenna. It was an 80-meter OCFD. And we'll be using this same OCFD later and looking at some different things. Here's a bunch of baluns that I tested. I had one other commercial balun that I used. It was a 4-to-1 LTG voltage balun, but I added my own choke, 1-to-1 choke, basically using the same chokes we see down here in this these hybrid baluns. And that worked quite nicely, actually. This was a commercial balun from a very reputable balun vendor in the States. He builds outstanding quality, but it was by far and away the worst balun in the test, and it's touted to be an OCF balun. And we'll see just how bad it is later. And after measuring, and I started out by measuring these dual cores. This was basically the hero out of my common mode current test in 2013, and it more or less fell flat on its face. And so I talked to Steve, and he said, well, you just can't get enough common mode current out of this dual core design. First of all, because these two, they're 1-to-1 gonellas, but when they're used like this, they're in parallel. You get only half as much common mode impedance. So in order to gain more common mode impedance, I had to use a single core 1-to-1 gonella. So then I got the idea of doing the hybrid balun. I looked at Andrew Roos, ZS1AN, has published an article in Quex magazine long ago about a hybrid balun, and I looked at it and I did not like it. I thought he's using the wrong choice of components, and he built it backwards. And so I built it the other way around. It worked quite nicely. I showed Steve my results, and he agreed it worked quite nicely. And I asked him why he was showing the way Andrew did it, and he said he just copied Andrew's stuff for his article. He didn't ever think about it, and so he was going to model my balun in Spice, and unfortunately he passed away before he got back to me. So anyway, as you see, I put a lot of effort into defining exactly which is the right kind of balun to use. Now, the OCF balun, what kind of balun should we use? In my opinion, there's only one balun we should use, and that is the hybrid balun. Now, the hybrid balun consists of two baluns. The top here, well, first of all, the primary job, as we learned last time, is to impede common mode current, and that's the lower balun. This is the 1-to-1 choke balun, the gonella balun. And the secondary is to transfer the impedance 4-to-1. Well, except for a 40-meter OCFD with its feed point near the center of the antenna, like in my tests 2 years earlier, it is impossible to do both tasks satisfactorily with a single 4-to-1 current balun, even if it's a dual core balun. You need an additional choke. So as long as we're going to add another choke, that we don't have to use a current balun for the transformer. And the reason is the CMI of we said that in the last slide, is only half as much as the 1-to-1. I just couldn't get enough CMI out of the 4-to-1s. But even worse than that, when you have higher SWR, the CMI of your transformer balun decreases. Not so with the transmission line balun. And the SWR has common mode current, and so it was decreasing the CMI, the common mode impedance of the dual core 4-to-1 Guanella. So I said, gotta go with a 1-to-1. So the hybrid balun, which Tom Rauch says it's called a compound balun. I said, well, Tom, in your commercial circles, yeah, but here in ham circles, we call it a hybrid balun. So a 4-to-1 Rutherford voltage balun is perfect for transforming the impedance, and a 1-to-1 Guanella is what we need to block the common mode current. So let's look at the Rutherford. This balun transforms 200 ohms from the antenna side, 50 ohms to the coax. The 1-to-1 Guanella choke balun used together with this balun has sufficient common mode impedance to block all of the common mode current. It doesn't need help or additional blocking from the 4-to-1. You could use a dual core 4-to-1 current balun, but why? There's no need. It's unnecessarily complex. But if you do want to use it anyway, and a lot of people do, then use it with a number 61 or ferrite 61. Do not use it with 43 or 31. Now, if you were using only a dual core balun, then you must use 43. A 61 won't work, nor will a 52, which is what was used in that balun that was worst in my test. 61 has a higher curry point and a wider bandwidth. It's the better choice for the transformer. And never ever use a single core 4-to-1 Guanella current balun. 4-to-1 Rutherford voltage balun is preferable over the dual core 4-to-1 balun. It's simpler, cheaper, smaller, lighter, easier to build. It requires only one toroid, thus less weight, less complexity, less cost. So how to build these things, and I think I said last time, everyone I ever knew, including myself, was scared shitless to build their first balun. And I never knew anybody who was scared at all to build their second balun. They're just so easy. But for some reason, I don't know, we were all afraid of it, Maybe it's like jumping into a lake for the first time when you don't know how to swim. And everyone says how easy it is to swim. But, if you don't know how to swim, you're afraid of it. So what you see on the right, first of all, the core, you're maybe wondering why it's white. This happens to be Ferrox cube. It's ferrite, just like the others. It's almost the same as an FT 14061, which means 1.4 inch in diameter, outside diameter. But Ferrox coated these baluns with a thin layer of epoxy paint. I prefer these for two reasons. First of all, you have nice smooth surface, and I build a lot of my baluns just on breadboards, or I call them backplane baluns or something like that. So I don't even have an enclosure. So I kind of prefer having a coat of ferrite, not ferrite, but rather epoxy over the ferrite. Although theoretically the ferrite isn't really damaged by water or anything like that, but I have a better feeling with that. This is a typical 4-to-1, and it's actually the one I use in my 40 meters OCFD hybrids. Okay, this is an example of how they're wound, and you can see I just wound 8 turns of twisted pair around to what I call a 3-pin connector. I build these myself. So you have one of each color fastening to the middle, and then the other one from each side goes to the outside. The coax fastens, the coax from the Guanella, from the 1-to-1 fastens as shown. The shield goes to where the two come together. The center pin could go to either side, but whichever side you put it at, you should connect the long leg of your OCFD. That's why I like using the black and red. I sourced this wire from DX Wire here in Germany. It's a Teflon insulated, silver plated, solid, number 18, about 1 millimeter diameter. And it's excellent for up to about a kilowatt. So 8 turns of twist. That's what I just said. I described it already. I use black wire ties because they're ultraviolet resistant. White ones are not. And here's the 80 meter. There wasn't enough room on the slide to blow it up big, but it's exactly the same, but it has almost twice as many turns. Now, how did I determine the turns ratio? I'm not going to go into detail, but basically I built these with more turns than shown here, connected a 200 ohm resistor, scanned with a scanning analyzer from 1 to 30 megahertz to see how they behave. And then I added more turns or reduced turns so that I could center the bandpass on the frequency I was trying to cover, so optimize for the band that I'm using it on. As for what components to use this is still the Rutherford, depends on the power. I actually did build one once for 200 watts, but only one. And for 600 watts, I use the 1.4-inch cores. There's the Amidon or the Ferox Cube part numbers here. You can use either one. And as you can see, the turns count over here between 80 and 40 meters. On the small up to a kilowatt, I use number 18, maybe even 16 you can go to, but the 18 is fine for if you're SSB CW, it's fine, certainly. Now maybe with Digi you might want to go to 16, and for 1.5 kilowatts I would go to definitely 16 and maybe 14. Just a note, I said this before, and a lot of people do it. I see it all the time. I've personally burned 3 or 4 commercial balloons that were rated a few kilowatts. Of course, I was running high power as well and contesting, and I've burned them up. And every time you'd see that the enamel was burned away and it burned into the core somehow. And I just will not do this. I will not use bare enamel wire. I always put it inside of Teflon, or I just buy wire that's Teflon insulated. And the only exception is when I build very, very tiny ones for QRP, where I know I'm only running 5 watts. But even then, I take the ferrite core because it's a bit rough, and when my XYL wasn't looking, I pinched a bottle of red fingernail polish. Well, I was going to show you, I've got it here, but I can't get my camera the other camera to come up. So, and I coated it with red fingernail polish. I thought that'd make it a bit smoother, and then I wrapped it with the thin bare copper wire. So now the guanella is just as simple. And there's 2 ways to wind the guanella. They're pictured on the right. They need the same number of turns. It's just it wasn't so easy. In fact, I drew a drawing and it wasn't very good. And this other friend of mine, he drew it, and I had too many turns on it. That's why it was not looking very good. So this just shows how to wind it, but you do need to get your 17 turns onto it for 80 meters. Less turns for 40. I'll show you that in a minute. So you can wind it, but it's wound. Both of them are wound contiguous. The top one in one direction. The bottom one has a crossover. It's called W1JR. It's Jerry Reisert, and he's the one that first published that. Now, had a discussion with Tom Rauch, WHJI, and he says there's a bit of difference. I said, for all practical purposes, I couldn't find anybody. He said one of them is a little bit better for the higher frequencies, better in CMI, and the other one's a little bit better in the lower. I can never remember which it is, so I have to go back in my files and look up what he said. But I've done it both ways multiple times, and I'm happy doing it both ways. So I use whichever one is the best mechanical and physical fit. Important though, if you do the crossover, the W1JR method, look how it crosses over. On the top, if I come off and over the top, then on the other side, I have to go under, or vice versa. But they need to be opposite. If you don't do it, if you do it the other way around, it's not going to work. So same as on the other chart, I'll let you read this. 600 watts a kilowatt, 1.5 kilowatts. About 5 minutes before the presentation was to start, I realized I had written 143 here and here. And I was then trying to patch things up and get it to work last minute. So anyway, I see all the time, especially a lot of the groups I'm in, antenna groups, most of the members seem to be in the States. I guess that's where most of the hams are that speak English. And the RG400 is very popular, and I never use RG400. And because I am not a bodybuilder like Arnold Schwarzenegger, RG303 is just as good. It's pretty much identical, but RG400 is double shielded. RG303 is single shielded. It's slightly thinner, but it's a lot easier to wind around the tori than it is winding this. You gotta, get Popeye to give you some spinach or something to have enough strength to wind the RG400. So it's hard enough winding anything around the toroid. But the good news is you don't have to do that often. Do it once and you're done forever. So my tip is go with RG303. If you're running really low power, you can use smaller, thinner coax, or you can use RG58. But for the higher power, I prefer always to use Teflon insulated. You're only talking about 3 or 4 feet of coax here, so there's not a huge price difference between the two. Oops, I got ahead of myself. Okay, I showed you this last time, and I wanted to show it again today, but I can't seem to get my menu, and I don't know why. No, I don't, maybe it's, let me see if I can get at it here, because I wanted to show you some things. Video. That one and background. Okay. Now I can show you some things. Here it is again. I think you remember I showed you last week. And just to show you the size, here's a Swiss Army knife. So they're about the same size, although the Ballon weighs twice as much as the Swiss Army knife. This is the white one here, the big one. This is the FT240. It's a 1-to-1 Guanella. Interesting coax. This is actually my favorite. It's sold by DX Wire. It's a little bit thinner than the RG303. It doesn't handle quite as much power. Easily handles a kilowatt, even in digi mode. And we're only allowed 750 watts anyway, so this is what I use most of the time. I don't have a can right now of the liquid electrical tape. This is liquid rubber. Yeah, I have to keep remembering this goes backwards to how you think. If I go left, it goes right. And, you coat the stuff like that, it's perfectly well insulated. But sometimes if I think I'm going to have to unsolder a connection, and when my XYO isn't looking, then I just use this and I coat it with the fingernail polish. And then if I need to take it off, fingernail polish remover does fine. You can take it right off and unsolder it and solder something else onto it. Okay, now I need to get rid of this stuff again. Okay, this is the one I just showed you. I used it, was in an enclosure when I did my battle of balance test. It also has 17 turns, cross wound. And I actually ran the test. I used just a 1-to-1 Guanella Ballon. I did not even use a 4-to-1. I just wanted to see what happened. It worked great on 40 and 80 meters. So SWR was only a little bit higher, was perfect, but the SWR was much higher on the higher bands. So it's, not to be recommended, but if you only wanted 2 bands, you're fine doing that. So what I ended up doing then, I wound on the same size core, the 4-to-1 Guanella. So I wound it just like over here on the left, but on a bigger core. That's on the bottom. And no, not Guanella, Rutherford voltage balance, sorry. 4-to-1 voltage balance on the bottom. Guanella on the top, and I put in 2 Teflon spaces here. Unfortunately, I could not get the lid back on the case. So I had to remove one. So this is closer than what I wanted it to be. But, it was the only way I could use it. So I put it on with just one spacer. And it seemed to work just fine. So this is how you connect them. I showed this earlier, but once again, this is how simple it is, And I use the 3-pin connectors, and I think it's important to have a very good, solid connection between the two. I don't want the wires pulling on wires. So balance did not have to be mounted in an enclosure. I've said that often before. K9 YC, who wrote the wonderful paper called RF Choke Cookbook, he even says in there, it's a pretty good idea not to use an enclosure. That way the balance can breathe better. They don't overheat as easily. Of course, he's always talking about running 1.5 kilowatts RTTY. So since I don't do that, I don't worry really about that. It's just trying to locate and buy an enclosure to put a balun it's one of the hardest parts about building an antenna. But if you build it open frame, and I'm going to show you in a minute how to do that, then it's much simpler. So it helps to use a 3-pin, I said, that connector, and we're going to take a look at that, I think, on the next slide. But if you're using the backplane version, you can just mount the 3 pins into the backplane. You don't need the connectors. And the advantage of the backplane version is that, the cores can cool. This is what my 3-pin connectors look like. They're about, well, let's see, what do we have in centimeters? 3 centimeters by 1 centimeter, approximately. And this is epoxy board. I originally built it out of plexiglass. I didn't like working with the plexiglass because when you drill, the plexiglass melts a bit and it kind of sticks to the drill bit, and all that is a mess. So once you've got them mounted in there, I got these pins from a German shop, Conrad Electronic. I buy them in packs of hundreds. And in the meantime, I've bought about 1,000 because I still build these for Spiderbeam. They don't have anybody that's willing to build these. So they build the antennas, but I've got to supply them with these 3 pins. So then you cut off the excess on the bottom, snip it off with a pair of wire cutters. And then you have to coat the bottom with epoxy to insulate it, but also to keep the pins from falling out. And I solder the balance to the 3-pin connectors so they're one piece practically before I put them into the enclosure or before I mount them to the back. Well, actually, that's not true. When I mount them to the back plane, it's the other way around. Let me start over. In the enclosure, I solder them to the pins and put them as one piece inside. The pins are on the back plane, so there I actually solder them onto the back plane. Okay. Now let's say you don't have the pins and you don't want to place an order to Conrad for just 3 pins. Well, here's a quick do-it-yourself. Take the same epoxy board, same size, and you drill 6 small holes, and you cut yourself a couple of 3 pieces of number 16 solid wire, bend them as shown, like a hairpin, insert them from one side, twist them on the top and solder them, and then turn it over, epoxy on the bottom, and away you go. You've got it. Okay, this was the very first backplane or open frame balun that I built. I built this a dozen years ago, and the plexiglass boards are available from DX Wire. So I bought a few of those, and I put this in an 80-meter OCFD antenna, and it had common mode current on it. So I added a choke, and it was quite good. I later learned I should have had a couple more turns of wire, so I later built these with a few more turns of wire, but you still always needed this choke. My beginning days, I was researching this. I built about 6 or 7 different 40-meter OCFD antennas with different feed point positions or splits, different types of balun. I even tried the Trask balun. They were talking about this is a new, much better balun. It's not. It's a piece of junk, in my opinion. And I'm not the only one that said that. Steve said it. Tom said it. It has common mode current problems. So this is basically the same balun over here, but this is on one of my own plexiglass boards that I cut out. And I tried it first like this, and then I added a 1-to-1 Guanella choke. And in this case, I just used RG174. It was just for low power. And all 3 of these were number 43. And I later learned these don't have to be number 43 if you have the 1-to-1 choke like this. But it worked quite well. So I said, even though I didn't know what I was doing, sometimes the blind horse finds its way to water. So another one of the ones I built like this, I wanted to try this piggyback method. Now, Steve G3UNA sent me a whole bunch of little round green plastic or something like that, spacers, and I stacked 2 of them together and put them between the 2 cores, but then I painted it all black, and so you could not see that there's a space. So I have drawn the space in here with PowerPoint. So there is I don't know, 1/8 of an inch or something like that space between them. And that's a dual core 4-to-1 Guanella. And just for comparison, I took a single core 4-to-1 Rutherford voltage balun, set it next to it, just so you can see the size. So it's, it's thicker itself, but altogether it's a little bit wider, but it handles much more power than this does. And it's number 61, not number 43. So in my opinion, that's the only way to go for the voltage balun. Now, construction of the backplane. Since I was building so many of them, I made myself a template, and I did it by drawing it up like I thought it should be, and then printing it out, and then laying my baluns on top of it, and then making it larger and larger and larger until it seemed to be the right size. So then I printed it out, measured it, and I came out with 13.2 centimeters. So that's the reason it's got the funny number, not 13.0 or something. It's just what it happened to be. So I've got this PowerPoint file, and every time I print it, it comes out with the right size, and it does all these dotted lines on it and all that. Now, you can leave it like this, or if you like, you can cut out along the dotted lines, because you don't need that for the strength. I quit using plexiglass. I switched completely to the epoxy boards. I wanted to show you that. Maybe I'll do that at the end, because I've got to switch cameras, and that's taken me too long. Although I did find my menu, and now it's back up top. Okay, so this is how I build them. This is what I just said. So this is what you do. You take the PowerPoint file, and you run it on your computer. You cut the backplane first, 13.2 times 13.2. Print the file, cut the template out, the paper template out, and tape it to the backplane. If you like, you can cut out along the holes, along the dotted lines. You drill the holes, mount the baluns, solder the SO239 connections and so forth, and you're good. So if you want to build it this way, you can download the PowerPoint file here. Now, I converted it to PDF. I thought that would be more convenient. Unfortunately, PDF reduced the size by about 10%. And I didn't feel like, playing with it again to try to get the PDF the right size. So I said, what the heck? We're just going to have to print it out in PowerPoint. I missed the title, so let's see what. Okay. This was interesting. About 5 years ago, a school in the UK, a Sandringham School, amateur radio club at the school, they were planning a DXpedition to Gambia, Charlie 5 DX, and they had some special requirements. And the guy that was the schoolmaster there, he was a ham, and he had already had an Aerial 51-404 of mine. He'd used that before, but it didn't cover 80 meters, so he wanted to have an 80-meter antenna. And he asked me if I could build him an antenna, all bands. He wanted 600 watts because he had an Elecraft linear. Had to be ultra lightweight, as small as possible. He did not want to use a tuner if he didn't have to. Everything should be plug and play. He had a 10-meter long fiberglass pole, which actually was a 12-meter spider beam pole, but he planned to shorten it by removing the top 2 segments. This made it very heavy duty then. And it was going to be on the hotel balcony, which was on the top floor, so he could extend it up. This is what I built for them. Actually, it's the same as this is my standard backplane here, balun, but with the excess fiberglass, not fiberglass, rather epoxy board cut out. After I built the balun, I coated everything with this black electrical tape or liquid electrical tape, liquid rubber. Notice, so the red here, that's the XYL's fingernail polish. And because I thought I've got to go test it, and if anything's wrong, I want to be able to take it apart. I was using very thin wire. This is AWG 26, about 1/2 millimeter in diameter, but it has a heavy-duty polyethylene jacket, and it's copper weld, stranded copper weld. So it's copper-plated steel wire, so it's strong enough. Now, the short leg is on the left side here. These were special insulators I built. I bought from DX Wire. Once again, they're mini insulators, and I cut them in half, and out of one insulator, I made 2, just to reduce the weight a bit. This is the short leg, the first part of the short leg. This is my capacitor bank. I'll show you this in detail later. This is what we had to build for the commercial antennas for spider beam, because they didn't like my homebrew stuff. And this is the long leg, and altogether the antenna weighed 500 grams, 1 pound, 1 ounce. And of course, they were quite happy. It was the expedition was a great success, and Spiderbeam sponsored them the pole. I sponsored them the antenna, and they had a grand time. Now, okay, that concludes the balun. I'll take questions on balance at the end. But this part is, yeah, like I say, my menu at the top covers my top line. So what is it? Where do we place the feed point? There's no such thing as the best. I'm always asked, what's the best place to feed it? Or I see discussions like that on several different groups on the internet. I think, guys, there is no best. And I mean, sure, everybody has their own best, but what's my best may not be your best, you know? The classic OCFD antenna, which is what most people use because that's what all the books say, and that's what most people quote, 1/3, 2/3. I do not like that. I would use that if I had a Yagi antenna for 10, 15, 20 meters, and I only wanted 80/40, that's okay. But as long as I want to use other bands, that's not a good split because it does not work on 15 and 30 meters. And I showed you why last time. Exactly where you place the feed point will depend on your band preferences. You may choose to optimize for as many bands as possible, optimize for your favorite bands, like contest bands. I skipped one. There's no position that works best on all bands. It's always going to be a compromise. Now, here's the important part and the unfortunate part. If you're a WARC fanatic and all that, on an 80-meter OCFD, 30 meters and 17 meters are mutually exclusive. Doesn't mean you can't work both bands with it, but you're not going to get low SW on both. You know, you can have low SW on either 30 or 17, not both. If you got it on both, you've got something wrong with your antenna. There's a lot of loss somewhere. So finding your feed point. We looked at this last time and I said, these were my two favorite places. So if I wanted to have 30 meters, I was going to go down in this low area. And if I wanted to have 17 meters and didn't care about 30 meters, then it would be up in this area. And I think most people, well, and since I built these before we had FT8, you know, everybody preferred this one because there's, you know, most people don't work CW on 10 meters. I do, but most people don't. So basically what you do is, you know, this is going to be exactly how we go to the field and we find exactly where we want our feed point, but we choose where we think we want it. So I said, you know, 29.8 was the best. Now these values here, I didn't choose them. This is what the computer model from K8BA spit out, you know, about every half percentage or so it had something. So I said in this range here we want to put it. So I started out in here. I ended up at 29.7, but this is how you get to it. So you go to the field and you put up your antenna. You measure the frequency at which minimum SWR occurs on the fundamental band on 80 meters, for instance. And you record it. You got to write it down. And this is sitting at, let's say, 29.8. And then you move the balun. Now you can go in either direction, but I moved it in 2-inch, 5-centimeter increments. Move it to the left, measure and record. Then I moved it back the other direction, 4 inches, 10 centimeters, which means it's 2 inches or 5 centimeters to the right. And you look which one is better. Well, in my case, I actually ended up better at about 29.7, you know, but in this example, I've gone the other direction. So if it was better here in, you know, to the right, close to the center, I move it again. Okay. I move it again a second time and it's still better. I move it a third time and you keep moving it until it gets worse. When you find the point it got worse and you go back 2 inches and say, hey, that's my best position. That's how you optimize the feed point position for the bands you're interested in. Of course, every time you move it, you got to go measure the bands and all that, you know, but this is how you can really hone in on what's optimum for your particular needs. I want to show you an example of how much difference there can be by choice of feed point. I did this a couple of years ago and I didn't yet have my new analyzer, which is Bluetooth enabled. I can now place my analyzer at the feed point. I don't need coax, and I can control it from the ground with my telephone, with my mobile phone. And at that time, I used a half wavelength of coax, and I chose 5 different splits. I'm showing 4. Version 1, 2, 3, 4, 5. Version 2 was so lousy, I didn't even bother to include it. It was not worth it. So I chucked that one out. So version 1, 3, 4, and 5, and measured 40, 20, 15, and 10 meters. And this is what I got. If you look at this 1, 3, 4, 5, and quite a difference, especially on 40 meters. Now, actually, this one in 40 meters wasn't so bad. When I later measured it at the feed point a couple of years later, it's down much lower. But with that piece of coax, that's the length it came in at. And 20 meters looked like this. And there's 15. And you can see in 15, one of them really looks ugly up at the top. Okay. And that was this classic 33.3%, which, you know, we said then the SWR is going to be terrible because the current crosses the 0 axis pretty much at that point. So it turns out it's about 7.16 to 1 at the end of a piece of coax. I later measured that when I got the scanning analyzer with the Bluetooth enabled. It's up around 20 to 1 or something like that. It's ridiculously high. So that's why I don't like that split. But if you don't need 15 meters, it's a good split. And then 10 meters look like this. And this is kind of all over the bend. Now, what is my favorite split? It's not showing on here. I didn't measure my favorite. It's actually the one that's in the aerial 51404 UL, 40.5%, maybe 40.6, about that. So, and when you go to 40.5, it drops this line quite a bit down. Okay. The reason I like this, you know, most people are only looking to SWR, but I did a lot of work at looking at common mode current, and you've just got so much less common mode current when you're close to the middle of the antenna. And I also know that, 3 to 1, 4 to 1 SWR with these short runs of coax that I'm using, that makes no difference to my signal. So I'm going to choose, unless it's just a terrible difference in SWR, I'm going to go with the one with less common mode current. Okay, and then over here, I just say I've been doing this for 10 years. I've made over 3,000 field measurements. Almost all of them are, saved. Quite a lot of them are online, but, others are on my computer. I have a pretty good feeling for what works, what doesn't work. And, you can trust my measurements, but by all means, feel free to make your own, and, we'll be happy to compare. The only thing I would warn you, one thing I learned, I'd always heard before of the 90-90 principle. Have you guys heard of the 90-90 principle before? Well, it's very simple. It says the first 90% of the work takes the first 90% of the time, and the last 10% of the work takes the second 90% of the time. And that's definitely not exaggerated here. You end up spending more time in the field than you think. So let's look at where the good feed points are. Now, this is derived from a combination of honing in on that monster spreadsheet that K8BA did, and then going to the field and measure these hundreds of measurements on these things. And here you can see the relatively, good feed points and bad feed points with, orange 4 to 1 is still quite usable. And actually, it was as good as I could get it on 30 meters. I could get it better, but then some of the other bands got worse. And as you can see here, at one point, I measured 26 to 1. Even that's even worse than I said earlier. And a 15, no, sorry, that was, I said 20 to 1 was over here in 15, and 26 to 1 was on 30 meters. That's at 33.3%. So if you want those two bands, do not use this. And looking at all these, I used this for about 9 years, but the antenna was down by the house. This was physically the better fit. And I did kind of prefer 30 meters to 17. But then when I moved the antenna up on the mountain, there wasn't enough room to fit this one in. I had to go with the 29.7% split. And I still work here with the antenna on 30 meters, but I have to use a matchbox. And yeah, I'm losing some power in the coax, but it's just the price you have to pay. It's always going to be a compromise. So these are, you can have a look at that. And like I said, you can use these as starting points. If you like, just use them as is, but you can also go and tune it as I showed you to tune it on a previous slide. 40 meters is quite similar. You know, I should have showed that before. On the left, you see CMC. Common mode current is always bad on an OCFD antenna. Of course, with the proper balun, we can control it. But the closer to either end, the worse it gets. That's why I, would prefer to have feed points farther closer to the middle. So on 40 meters, I did actually go with one here, 40.5%. That's my favorite down in here. And, some people, K1POO years ago published a QST article. He had this. I've built this and used it. It works just fine. But I like this better because you have less common mode current. So, as I say, don't forget CMC is always an important factor. Now, the bottom, I didn't know whether I should put this in or not. I'm not going to talk bad or good about any manufacturer, but I will say there was a window manufacturer in Virginia. They no longer retired, so they closed the business. And there's a balun manufacturer in Texas who both claim that the OCFD cannot work on 15 meters. And the reason is it was never designed to work on 15 meters. And I said, well, that's nonsense. First of all, the original one was built before we even had 15 meters. But second of all, it's just a matter of moving the feed point. So they're wrong. They don't know how to make it work, but we do. By the way, I've built all of the, except for the 33.8, I've built all of these in the past and verified the model. So I think that said wire straights, kind of like dire straits, or we could also say wire traits, as you shall see. So like I said, it's not how long you make it, it's how you make it long. Here I have the exact same antenna. Spiderbeam sells these. I built these for myself, but Spiderbeam sells them too. And the one is the heavy duty version. It's got thicker wire, and inside the balun is potted with 2-component epoxy. The lightweight one has got much thinner diameter wire, weighs a lot less. And it ended up, this one is a lot shorter, the lightweight one, than the heavy duty one. Over the years, we've had to change wire a few times. In fact, we've changed this thin wire. Well, our fifth revision of wire, we had to change 4 times. And you can see that there wasn't a lot of difference from going from we had first the CQ534, we went to the DXWUL. We've just changed again to Davis RF Polystealth 22, and every time we got to change the links. So if anybody asks you, how long did you make your antenna? So, well, I can tell you how long mine is, but that does not mean that's how long yours is going to be. It's going to depend on which wire. So unless you state a wire's length, or if you state a wire's length without specifying the type of wire, it's a pretty meaningless number. This is kind of the trick question. How should we measure? Feet and inches, meters and centimeters. In the meantime, I prefer meters and centimeters, but since I learned in feet and inches, I always do the math. I calculate in feet and inches, convert it to centimeters, and then I build it in meters and centimeters, but actually both of them are wrong. The correct way to set the length of your antenna, we set it in megahertz and kilohertz. Of course, we start out with a starting length using meters, the formula in either in feet or in centimeters. But once we have the starting length, from there on out, we're looking at megahertz and kilohertz. So the way we do it, and I think I showed this last time too, but you always cut it a bit longer than you want. You fold it back at the insulator, wrap it around itself, use a wire tie. That way you can adjust the lengths. So I'm showing the target lengths I recommend for starting. It varies a little bit with the type of wire, but if you cut it to these frequencies and these lengths, it's going to be too long normally. And so then you only have to shorten it. But if it ends up being too short, you can always let some wire out at the end. Okay. So these are my recommended starting frequencies for the minimum SWR on 80 meters, 3450, and on 40, 3690. And I usually end up here at about 6980. And I end up at about 6990 to 7000 most of the time with these. This usually sometimes ends up at 3450. I've had it at one location be as high as 3480, but it's usually 3460 or 3470 after I've done the tuning. And we'll look at the tuning in just a second. So now we're going to go to the field, look at tuning. So Don't forget your Wellingtons, because it always rains when I go to the field. That's why I use waterproof analyzers. And of course, we go to the field. Before we go to the field, we shall assume the balun is already built. You've chosen your favorite feed point positions. You've cut the wires to the lengths I showed on the previous page. We're going to use the 80 meter as an example. So we attach 2 pieces wide of the balun using the suggested temporary starting lengths on the slide 28. Looks like this. Both ends are folded back so that we can adjust it. So in our example, we're going to take an 80 meter OCFD, a 3070. I mean, I use 29.7, but this 3070 is better for mathematical reasons. So this is just showing how to do it. So 3450 as our minimum SWR, and it's 136 feet, 41.45 meters. We read all this in the last one. You can't tune the bands individually. Every time you make a change, you're going to change all bands at once. And we're not going to worry about 80 meters yet. We'll do that as a very last step here in the tuning procedure. We adjust overall length while maintaining the split ratio for best compromise on 15 and 20 meters. Adjust the feed point split ratio for best compromise on 15 and 12 meters. I think I talked about that last time. Once I get this 15 and 20 here, I adjust for 15 and 12, because at 29.7, at 29.3 or 4, which would be maybe optimum for the normal classic bands, your SWR on 12 meters is about 7 or 8 to 1. And if you carefully tune it, you could raise the 15 meter SWR just a tad, and this drops to about 4 to 1, which makes it a very good antenna on 12 meters. So if you want to work 12 meters, you probably need to fine tune the split ratio. If that's not so important, just leave it at 29.7. Then after you've got the lengths all adjusted, you move your 80 meter SWR minimum to your chosen frequency. Now I'm saying, hey, let's go to 3700 or something like that. I mean, we all have our favorite where we want it. By the way, the 40 meter OCFD has the exact same problem. 15 and 20 meters move in opposite directions. And we'll show you this in graphs. Adjust overall length for best compromise on 15 and 20, just as we did on the 80 meter OCFD. Now it's time to tune the antenna. Okay. This is where we're going to fine tune the lengths and so forth. So the first thing we do is we've got a chart here showing all the bands. It doesn't show 6 meters, but all of the bands that we're later interested in. But for tuning purposes, only 3 matter. We begin by setting minimum SWR at 3645, we said, but we're going to scan, setting a center frequency near the center of the band and scan a megahertz wide, so we'll have a curve below and above the band. Then we're going to go look at these 2 bands, 20 and 15 meters, and see the shape of the curves and see how they look at each end of the bands and see if we need to prune. By the way, if you don't have a scanning analyzer, I'll show you how to do that on the next slide, next 2 slides actually. And we're going to have a look at this in a second, exactly how to do this. If you don't have a scanning analyzer, well, I made a chart. To begin with, on 80 meters, we're not interested in inside the band. We're interested in finding the best point below the band when we're adjusting the overall length. And, this is where I said we want to target. And once we get the overall length adjusted to begin with, that we're down around here, if we're plus minus 5 or 10 kilohertz, that's okay too, because we're going to have to change anyway when we look at these bands. So then we scan these bands and we fill in our chart here. This is like with an MFJ 259B, which is how I did it for almost 2 years. Let me tell you, it takes forever to do it this way. I'll show you in a second. So the 80 meter fundamental, I was measuring this every 10 kilohertz. The 20 meter was measured every 50 kilohertz, as was 15 meters. And remember, this is where we want to try to get it to land. Now here, I went and filled in all of these things manually with my 259B. It took me forever to do this. I've taken a shortcut by saying I got lucky, and my minimum SWR on 80 meters was at 3450. If it had been higher or lower, I would have had to trim a little bit. Then after I trim this, then I go down and look at all these. But I'm going to show you how much nicer it is to look at these on charts. But before I do that, let me show you what I get a lot. And believe me, I get a lot of emails. I get 100 emails a day. Most of them are just trash I throw away, but I get lots of people saying, what do you think of my antenna? And some of them are people that are using spider beam stuff, so I have to answer them. But a lot of people just stumbled on my website and they send me their stuff. And if you look at this, this was my first scanning analyzer. It only measures 100 data points. And when I scan the entire HF frequency, you only get a measurement every 280 kilohertz. Sometimes that's not even inside the hem band. And it interpolates in between. So this is pretty much a worthless graph. This is even better. This is a real case. Some spider beam customers sent me this and said they had funny shapes and trouble with their antenna. And we found the problem and fixed it. And it turned out to be a broken wire inside the balun. Anyway, they think this is good because if, I said, scan them for me and send me the results. I neglected to say, load your scans into the computer, upload it into the computer. These analyzers come with good software. So you can save it, your scan to the analyzer, then you can upload it to the computer and send me the data file, So these are probably even worse than the other one. The only thing is it does show you minimum SWR. That bit it shows you, but it's pretty worthless. This is what I'm looking for. This is what you can get. If you load the files taken with these scanning analyzers, and in this case, Rig Expert, into your computer, you upload them to the computer, and then you look at them in AntScope, which is a freeware software that comes with the analyzer. You can print out the curves. Now let's look very closely at the band ends on 20 meters and 15 meters. And you see 20 meters is a bit high in SWR on the high end of the band, and 15 meters is a bit high on the low end of the band. So we can shorten or lengthen the antenna, but one of the bands is going to get better and one of them is going to get worse. So I looked at this carefully and I said, well, this one's going to be pretty low no matter what we do. Let's optimize 20 meters and move it just slightly to the right to lower the high end of the SSB band to try to make it symmetrical across the band. So I said, this looks like, and it looks like I measured it. That's the beauty of this AntScope software. When you run your cursor along, it actually shows you frequency and well, it shows you all the characteristics. So 50 kilohertz too low. You need to raise it 50 kilohertz on 20 meters, but not 50 kilohertz on 80 meters. So if we say 50 kilohertz on 20 meters and then 3.5 over 14 times 50 is 12.5 kilohertz. I called it 13 for even numbers. So I want to move my SWR minimum from 3450 to 3463. And I know my length was at 41.45. So I say 3450 over 3463 times 41.45. The new length is 41.19. So I need to shorten it by 26 centimeters, but proportionate to the split. So shorten the short leg 8 centimeters and the long leg 18 centimeters. All right, so that's how we can look at these graphs and so forth. Of course, what if you don't have the graphs? Where can you get these kind of graphs? So for viewing, and AntScope is a freeware software, and in my opinion, it's the very best software for evaluating it. But there are very few analyzers that save in the freeware file format. Doesn't matter because the freeware can also import all sorts of file formats. If you've got a Rig Expert, well, first of all, you can download, all of you right now can download this software. Just follow the link that comes up here. It should work in the PDF as well. Download the software. It's a freeware for the moment, and it has always been, but rumor has it it's soon going to be, they're going to start selling it. I have no idea what price. So I recommend everybody download that tomorrow or on the weekend or something before they start charging for it. And with Rig Expert analyzers, which I love, the software comes with it anyway. You don't have to do anything. But a lot of people nowadays are going with this nano VNA. It's a good. It's not really an antenna analyzer. It is a true vector analyzer. But the software that you usually use with it, I don't know if you can even save with that. So what you need to do if you have a Nano VNA, you need to download and install another freeware called Nano VNA Saver. And I think it's from the same company, Nano VNA Saver. And then you run Nano VNA Saver and you make your measurements with your analyzer from that software. And with that software, you can take each measurement and you can store the individual band measurements on your computer. The file format it uses is Touchstone format, which is quite a common format for not analyzers, but VNAs. Okay, and once you have all of your data files stored in this format, then you run an AntScope on your computer and you import the individual files one at a time. And that brings them up and it displays them in AntScope, and you get the exact graphs that I showed you on the previous pages. Okay, here's 40 meters just to show you it works the same way. Once again, better is in opposite directions. So it's always going to be a compromise. And I think these two graphs were done after I had already optimized it because they look pretty good as is. Bottom line, you can't have your cake and eat it too. It's always going to be a little bit of a compromise. So we're very close to finishing. The only thing left is to set the minimum SWR in 80 meters. Now we looked at last time how we're going to do this. We take our new length of the antenna. LL is long leg, LS is short leg, or SL, short leg. And we add them together, take the overall length, divide by 2, that's the middle, and we cut the wire there. And we're going to insert our capacitor board here. It's got a resistor and 3 or 4 capacitors in parallel. And I'm going to show you why the parallel. Approximate picofarad required. If you're looking for the CW range in Digi, about 600. If you're looking for our region 1 SSB, about 380. In region 2 SSB, if you want to be in the low end of the band, 3800, it's about 200. A lot of people have a general or technician license. They're up around they operate higher. It's about 140. And by the way, all of these capacitance are valid for the 29.7%. When you take a different split, they're going to change, but they're not going to change by a lot, but they are going to change a little bit. But these are pretty much the values we use in the Spider Beams version of the antenna. And I think I showed this chart last time, but anyway, this was calculated by a friend of mine. It's he's got a PhD RF engineering. So he went through various power, and I asked him just for these 3 power levels. And depending on how much capacitance you end up using, you're going to need a different value of voltage and current. So you can look at this chart to determine how much voltage and current. And, by looking at this, I would not want to run 3 or 4 amps through a thin little wire like this. So I'd be putting 3 or 4 or 5 capacitors in parallel to reach whatever value I needed. Of course, when I presented this to Spider Beam, the boss said, well, we can't sell that. Your capacitor board looks too homebrew. So we had to design something new. So we designed this. It's a printed circuit board, and this is outsourced as a company builds these. And it has, if you look closely, these 3 longer black ones are resistors. These are power SMD resistors and power SMD capacitors, 10 mega ohms each, and it's 4 kilovolts resistors. And the capacitors used, this is the region 1, where we're looking to get at about 3700, 3670 something. We're using 27 picofarad, 4 kilovolts, and there are a couple of spare slots that are empty here. And I can prune the frequency of minimum SWR by adding or subtracting capacitors. You don't want to take too many out, because then you would maybe not have enough current handling. But each time I took a capacitor out on this board, it moved about 30 kilohertz up or down. Put one in, it went down. Take one out, it went up. I think that's right. Yeah, that's right. Okay, so that's what I ended up going with. And I still build it both ways. Actually, I built 3 antennas for EMO for the for his expedition. They only used one, but we didn't know which ones they'd used. And in two of them, I put capacitor banks in there. One of them, I used one of these, and the other one, I breadboarded like I'd shown you, my original one. So I did it both ways. Once they're encapsulated in heat shrink tubing, they can't see it anyway. The very last thing we want to do, we're done with the antenna, but we do need to control it, so it's nice to just trust it, but controlling it is much better. This is the same chart on the previous slide a while back. Shows 6 meters as well, and this just shows you where you scan, and you can go through and scan and then look at all of them and see that everything's where you want. Now the bad news is we set 80 where we want it, and we've got 20 and 15 for a good compromise. We might have adjusted for a compromise on 12. But where 40 meters is and 17 and all that, we can't change them. They are what they are. And if my transceiver and my amplifier were happy on all bands in the contest bands. But for CW and SSB, when I was switching contests, I had to swap out the capacitor board. I had one for CW part of the band and one for SSB part of the band. And then I did not need a tuner. I used my station on all 5 bands without the tuner. Now, 2 more tips I promised you, and then that's going to be the end of the presentation. I had a real good friend who was also a silent key now, but in 2015, I was home. Actually gave a workshop on OCFD antennas in Oklahoma City back then, which he organized, and we built him this antenna. It was a 20% split, and I was able to run it flat top horizontal in a single direction. He had skids every day on 80 meters with his friends, and always had a good strong signal. He retired and he moved to a beautiful lakeside direct waterfront house, but his yard was not as large as the old one. He did not have room for the antenna, and he asked me what he could do. So this just says what I just said. Not enough room, so I had him do this. Bend the long leg. So he had a couple of trees. He had a tree here and a tree out front, and we mounted the pole right next to his what do you call it in English? The place where he docks his boat. Boat dock, yeah, that's it. We mounted the pole, fiberglass pole to the boat dock, and short leg over here, long leg down here, and put another fiberglass pole up, bent it 90 degrees out front. Kept his same skids every day, and all of his buddies said they could not tell any difference at all. So if you think you don't have enough room, we'll try it this way. This one is a tip that I think is very, very useful. I've learned this myself. I've never seen it printed. I've never read about it. I've never heard about it. And I think it's one of the most valuable things anyone can learn who's planning to build an OCFD antenna. It's a simple test to determine if there is residual common mode current on the OCFD antenna's feed line. Very easy to determine. You start out, you measure the frequency of minimum SWR on the OCFD antenna on the fundamental frequency. I should have put that in the slide, but maybe I'll do that before I do the notes. On the fundamental frequency, 80 meters, in other words, or 40 meters, you write it down. Frequency. Then this is assuming you can separate your coax from your balun. You insert a good Maxwell choke, a 1-to-1 Maxwell choke between the balun and the coax. Looks like this. I can show some of this stuff after I turn off the presentation and get my camera adjusted right. So and these you can build these yourself. I build lots of them myself. I got 4 or 5. I always have 4 or 5 or 6, but I'm always giving them away, and then I have less, and then every now and then I'll build another couple because I use them for all sorts of things. Next thing you do after you insert this choke between your balun and the coax, you measure SWR minimum again. If the frequency of SWR minimum has significantly dropped, there was residual common mode current on the coax. Your balun was insufficient. Here's an excerpt. I showed some of these in the previous presentation. I've got a lot more of these, but I've just chosen the 4 best that kind of say what I want to say. B3 was about, this was taken from the Battle of Balance test in 2015, 16, and 17. Was actually all summer 2015 and 16 and just 1 month into 2017. The first balun was that one that was the loser, you know, a commercial balun, excellent quality. And actually, it's not a bad balun in an antenna like maybe a full wave loop or something like that, or maybe even a folded dipole, but absolutely terrible for an OCFD antenna. Okay. And if measuring with just a balun, it came out at 38.85. Remember, we had around 34.50 or something like that where we're shooting for. So if I added this choke, it dropped 285 kilohertz with that simple choke. And this choke only has 1,000 CMI on 80 meters. So this had obviously heavy common mode current on the transmission line. B5 was a balun I built. It much resembled this one, except I didn't have it in a case. And it uses the same size cores, but mine had number 43. This one had number 52. I have 850 permeability here. What's it? 250 up here. And I used 17 turns of transmission line on mine, and they have 11 turns up there. The result was mine came in at 35.30. Not bad, but also not perfect. And so I added this choke and it dropped to 34.55. Okay, there might be just a tad of CMC left, but it's not even worth bothering. You can use it just as is. So that would be a very fine balun if you add this choke to it. Then I built, here's a couple, I built altogether 3 or 4 hybrid baluns at the time, different size cores, etc. Here's a couple of them. The top one is using, B4 was using the 2.5 inch or 2.4 inch cores. By itself, it was at 34.50. And when I added the choke, still 34.50, no, 34.40. It did not drop in frequency at all because there was no more common mode current to be eliminated. So you did not need to add a choke. B10 uses that's the balun that I use in these 807 antennas, using the 140 Fahrenheit, so 1.4 inch. It was at 34.50. 34.50 made no difference. There's no common mode current at all. So bottom line, you don't want to even begin with something like that. I wouldn't even use this anymore. That's how I did it 5, 6, 7 years ago. But now there's only one way to go, and that's the hybrid balun. I would never use anything but a hybrid balun building something new today. And guess what? That's all, folks. We're going to open it up for questions. Before I do, this is all the same information as last time, only the link to the commentary page has changed. Part 2 is a different page from part 1. If you want to email me, please use this and none of my other email addresses, because as I say, I get about 100 email addresses on the others. I get maybe 2 a day or so on this one. So you get a much quicker answer using this one. I have 3 websites. The Aerial 51 is mostly to do with Aerial 51 products. dj0ip.com is where I have all of the information pertaining to this presentation. These commentary pages are on there, except though, long ago when I did my common mode current test and I did my battle of balance test, I didn't have the new web page yet, didn't need the new web page yet. So those tests are located back on that one. But if you go to the commentary page and then look up the slide number, the link there will take you right to the tests. So with that, we'll open it up to questions.
Brilliant. Thank you very much indeed, Rick. That was a really good complimentary talk, Rick, to last week's one. Right, who wants to go first with a question? Any questions to Rick? Yeah, Darren.
No, sorry, Nick, I was just applauding the presentation.
Thank you.
Yeah, no problem. Right, anyone with a question to Rick?
I did switch my camera so I could show you just a few of these things I wanted to show earlier. I talked about it. See if you can see this. This was one of the first ones when I was building single core balance. I got to go. Oh, am I doubling with somebody? Okay. And I ordered a whole bunch of these, and I only used one or two. And I thought, no, that first of all, they're too small for what I want to do. And I went away from plexiglass anyway. And I went to these printed circuit boards, but without any copper on them. And I buy them on eBay or Amazon. They come in all sorts of sizes. I usually get them about 50 centimeters long and maybe 25, 30 centimeters wide. This one is, that's 3 millimeters, I think. I use them. This has already been cut a lot. This is 1.5 millimeter. And here's another one. This is 2 millimeter wide. And these make and the 2 millimeter wide that's pretty much my favorite that I use most of the time. Fantastic for building these backplane balance. They don't cost much. You know, you buy a piece of it, you can build 6 or 8 balance out of it. So that's what I would recommend for that. And the rest of the stuff I think I've already shown, but it's just so simple if you don't try to put it into a box. Okay, Nick.
Yeah, brilliant. Thank you, Rick. Rick, I've got a question to you. No one else was waving at me at the time. On your slide 7, when you were talking about one of the things you discovered, and that is that if you don't run the coax straight down and you pull it across to one side or the other, you discovered that that increased the common mode current. So my question is, when you're running the off-center fed dipole, as you do in those Aerial 51 designs, and I do at home with mine, as an inverted V, does that, so you're bringing the end of your cable just a little bit closer to the RF cable you're feeding it with? Does that make any difference to the common mode current from any measurements you've done?
No, normally not, and I'll tell you why. It's not a question of how close the coax is to the wire to the radiator, but rather you have 2 radiators, and it's how much power is being picked up from the one and from the other, because they're out of phase, you know. And if you're getting equal power from both, they're out of phase, and so you have no common mode current. But if it's closer to one side, you're probably getting more power from that side. That induces common mode current into it. Now, the funny part. So I'm thinking, okay, it's radiating straight into the coax, so it really shouldn't matter which balun I use. Well, it does, and it's significant. And I can't explain why, but I can show you dozens of measurements to prove it. So, well, you saw it yourself earlier on comparing the single core to the double core. There was just a whole lot more current in the coax using the single core than there was the double core. I also tried pulling it to both sides. You know, I repeated every one of those measurements. I repeated by skewing it to the other side, to the short side. Didn't make any difference. I had the same, might have made a tiny little bit, but, you know, basically the problem was the same. As soon as it gets significantly closer to one side, you start to pick up a lot of common mode current. A good balun, and I'm assuming, because I've never run that test again, I'm assuming the hybrid balun is going to be far less susceptible to that. It has much more common mode impedance than I was getting out of those dual core baluns. But I mean, if you skew it far enough, you're still going to get common mode impedance on it. Now, what I didn't show here, what I did also on that was skewing it to worst case, where you could see so much current into on the feed line. I went down to the transmitter end, and I tested 4 different kinds of chokes, and I tested these Maxwell chokes like I just showed you. One was a TG3 line isolator from RadioWorks. One was GM3 SEK, I think is called, Eon White. He's come up with a novel way of low-cost building high-quality chokes using these funny hunks of ferrite and then running loops of coax through them. So, you know, a little bit wider loops. And he had 3 different ones, one for low band, one for high band, and one for mid-range. So I used the mid-range, and I tested that. And then I tested my 1-to-1 guanella. Well, like this one. Where am I at? Can you see it?
Yeah, we can see that. Yeah,
that one. Yeah. So that one as well. The 1-to-1 guanella was by far the best. Well, by far the best of the 2 worst. The GM3 SEK was almost as good, would work just fine. So the only thing is the GM3 SAK was about 5 times larger than mine. So and I think at the time he did it, for some reason, toroids, they used to be extremely expensive here in Europe, but eventually the prices came down. So at one time I would have seen an advantage of doing it using his, but in the meantime, I don't see an advantage to using that circuit. The other two, they were basically lousy. So using the GM3 SEK or my 1-to-1 Guanella, and using the both of those two balance that I showed on the dual core, I was able to completely eliminate the CMC at the transmitter. With the other one, with the single core, there was still a little bit left, but it pretty much got rid of it, using another choke at that end. So, but at the end of the day, you really have to know what you have. You have to know what tools we have, and you can conquer common mode current almost all the time. But the best way to conquer it is to avoid it. We do that by using a good balun and choke combination at the feed point and running the coax 90 degrees to the antenna as far as we possibly can. I was quite pleasantly pleased because with my 404 UL, when Spiderbeam first started selling those in 2015, one of the first customers took it on a de-expedition to some island. And I don't even recall where, but he was in a hotel room and he had to string it from the balcony to a tree somewhere. Then he had to run the coax back to the balcony. So it was basically like my worst case scenario. And he did not have trouble with common mode current, but he wasn't running a lot of power. So maybe he got lucky. I don't know. But if he had been using the balance that some of these other vendors are selling, he would have had enormous problems, I'm sure.
Yeah, sorry, that reminded me of my second question. That was, does increasing power make a big difference does it make a greater difference to the CMC? Do you get a higher common mode current? I take your argument that there's always going to be some common mode current on there. But when the higher the power you run, does that have a detrimental effect on creating even more common mode current because you are running higher power?
Well, I'm going to give you a flaky answer. The flaky answer is yes, but I can't say how much. Okay. So I ran my common mode current tests for the 404 for the 40 meter up the mountain, and some of you have seen I showed less than the QTH. I just couldn't carry my linear amplifier up the mountain, so I ran 100 watts. And when I did the Battle of Balance test in 2015, I had no room up the mountain. We have a lot of forest, a lot of trees all over the yard, and I had no room for an 80-meter OCFD. And a friend of mine, he lives about 30 kilometers away, and he has a big field, and so I did it at his big field, but it's not near his house, and there's no electrical power, so we had to run off of batteries. So obviously there was no amplifier either. So I was never able to ascertain how much. But when I was running here at the house, I didn't have problems with it. And I had the antenna very close to the house, and it kind of zigzagged back, and I was running 750 watts. And but I had good balance, and I also had a choke at the house. So, but the answer is yes, it must, but I can't quantify it. So sorry.
No, that's okay. All right. I was just interested if you discover that. Okay, right. Anyone else with any questions to Rick? Here's your chance to ask a question.
In case you guys are wondering, I'm paying Nick to ask questions.
No, I made a note of those, Rick, as we were going along.
Well, yeah, but
anyone? No, seriously, anyone else got a question for Rick? I'm sure one or two people in the room have. Don't be shy. Yes, go on, Darren.
I've got a comment, not directly at Nick. Sorry, Rick, I get it right. More to you, Nick, and maybe to Gerald. I find this aerial very interesting, and maybe it would be an idea to try and build one as a club, and then test them on site somewhere, maybe up at Farnley, rather than just a random antenna, which I think we tried to do last time, but to try and do the specific antenna. We'd obviously need some sort of cutting list and get parts of people who are interested and get people to commit to paying the money out, etc. But it just a thought.
I think that's a very good idea, Darren. I mean, I think we you know, when we were up at Farnley, we've been trying to. I've actually brought a couple of times the 40-meter version of Rick's OCFD with the hybrid balun in it, and it's worked extremely well. But I've never tried. I've never had the space personally to run an 80-meter one, even taking Rick's design of wiggling it around the corner. There'll be too many wiggles in it, I think, creating some problems. But we've definitely, as Darren, you're right, we've definitely got the space to do that at Farnley, and I think having some people having a go at building the baluns, and then obviously the actual building of the wire bit of the antenna is pretty straightforward, isn't it? I think it's a good idea, because if we've then got a multi-band antenna that for 80 meters, as Rick's described there, that works extremely well, virtually without an ATU on most of the bands, that is kind of what we want, isn't it? Without sticking in Richard traps or other kinds of designs, or relying on an ATU to bring the match to be acceptable for the transmitter. So no, I think it's a good idea. I think we should do that.
I have two comments on that. First of all, for somebody wanting to build one antenna by themselves, and they've never, they're not like we are, Nick, crazy and build lots of antennas. And then if I need something like a toroid, a special toroid that I don't have, I'll order 4 or 5, but most people aren't going to do that. And the problem is you need so many different bits, even heat shrink tubing, and, you need the not fiberglass, but the plexiglass or the FR4 material. And you end up ordering from different places, and the postage costs you more money than the parts do. But if 4 or 5 people want to do a project, then you can, order from all at once, and then you can split the postage and all that, and it lowers the cost. So that was the first thing. And the second thing, there's another thing about the 807 antenna. I think it's unique in the industry, and it's one more time where this blind horse found his way to water. So there's a very famous DXpedition guy here, Ham, in Germany. And I probably won't remember his call sign. Most of you, if you've been a ham for a long time, you can recall about 40 years ago, there was a German DXpedition to Spratly Island. Mm-hmm. And just as they were getting to the island, their ship was sunk by, I think, Vietnamese army or something like that. And one guy was killed immediately, and then they were stranded in a boat for 10 days. And then on the 9th day, a second guy died, and on the 10th day, they were rescued. But anyway, Valdor, so Valdor is his name. His DK6SI or something like that. He wrote a book on the 10th day, you'll be rescued. And I don't know if he wrote it in English or not, though, but it was all over the news, even, normal news about the hams dying and all that. So he was going to go to Madagascar, and he'd heard about my antenna because another friend had just used it to place first place overall worldwide in the IOTA contest. He asked to borrow it. So I loaned him the same antenna that Paul had taken to the island, and he took it to Madagascar. And I was really anxious, because it's a really experienced DXpeditioner. I was anxious to find out how it worked. And when he got back, I asked him. He said, I didn't use it. Man, I was heartbroken. Why? Why didn't you use it? He said, well, I got to my hotel. There wasn't enough room to put it up. So I just used a piece of wire, random wire, and a matchbox. And I thought about that, and I thought, that can happen to just about anybody. And so I took a look at the antenna, and you notice that I have a short leg and a long leg, and the long leg is broken at a strategic place, and I insert a capacitor bank. Well, I looked at the links. I said, those links sound familiar. That was almost identical with my 404UL. And I said, I'm going to set the links to be that of the 404UL. So I moved the capacitor off center, but just a little bit. I mean, this was 7 years ago. I can't remember how far, maybe 20, 30 centimeters or something like that. I moved it off center just a tiny bit, and I don't even remember which direction. And I cut it there, and I inserted it there. It made no difference at all to the 80-meter operation. But when I removed the capacitor bank and I removed the wire, it was a perfect 40-meter OCFD. And so I built the 807 antennas such that these capacitor, I call them RMUs, remote matching unit. The RMU, you can unscrew it with a screw at each end and you can swap them out. You know, I change between CW and SSB and all that, but you can also just unscrew it with one single screw and you've got a 40-meter OCFD. And then lo and behold, I told you about the C5 DX Expedition. They were in two different hotels. In one of the hotels, they had no room for an 80-meter, so they cut it down and made a 40-meter OCFD out of it, and they used it like that. I don't think anybody else has got an antenna that can be configured as two different antennas with just one screw. You know, you need an insulator. There is none. There's just a little solder lug with a hole in it. So I say, just take a wire tie, put it through the hole, close it, and use that as an insulator. So, and then cut it off when you're done. And so lots of people, and I've used it like that too. And I've had people even in the past ask Spiderbeam if they could have a high power 40-meter version of the 807. And I said, well, just buy the normal one, and Spiderbeam would sell it to them for reduced price and use it like that. In the meantime, Spiderbeam has made a product out of that. So they're actually selling it. They call it 404 HP for high power or something like that. So in fact, I don't know if it's even up on the website yet, but I just completed the text a couple of weeks ago, and they're going to be selling because we get lots of requests for that. But it was a unique bit, and I use it both ways.
Okay, thank you. Gerald.
Hi, sorry. Thank you very much indeed, Rick, for that. It was a really interesting talk on that. I did a bit of experimenting, shall we say, with off-center fed aerials many years ago. In the days when the first one I saw was a Wyndham, was just a single wire feed, and
yeah,
so I used coax feed at all. So that's new for me. But I used to use twin feeder or homemade ladder feeder and so on. So this has been really interesting watching what you've talked about. I'll just second what Darren said as well, Nick. I think it's a good idea, Darren, and we ought to get on and design get some of these designs put up and try them out.
But Gerald, I also agree with the point that Rick just made there in reply that if we're going to do it, it might be worthwhile as a club buying a pile of toroids, so that if we've got people who say, actually, I'd now like to buy one myself, we can either sell them one very cheaply or give them one from the club. A bit like Roger with when you bought your boards for your EMR thing that you were building from Radcom, Rick's right, you reduce the cost of buying this stuff because you're not paying for postage every time you buy it. You're paying postage once instead of 6 times. So
yeah, once a while since we did the same thing building traps. And we picked up the stuff and built them all together as a group. I think Darren may remember that, and Roger, I'm not sure, but that worked quite well. Yes, I appreciate the point you made there. Oh, Rick, another thing I found with the off-center fed that I used, they could put the short end at right angles to the main length, and it seemed to not make any effect at all on the overall effect of the antenna.
Yeah, I haven't tried it that way. I've had people do that. Sometimes like vertical, go vertical up the pole, and then the short leg went horizontal near the ground, and they didn't report back any problems. The question could be, how much power were you running? And was that in the field or was that next to the house?
Yeah.
So I'd like to comment on feeding it with open wire, and I've done that in the past too. And by the way, like you, I began with a single wire fed. I think I said that last time, and I met all my neighbors right after that because I messed up every TV in the block. That was 1963. And later I tried it with the actually the open wire fed or ladder line fed version of the OCFD was really popular in the end of the 1930s and throughout the 1940s. And sometime in the late 1950s, where the first coax ones came into being. And it was maybe okay to do it back then because it was we had a different environment. Today, our households are full of wall-to-wall consumer products. Everything's got computers in them. Quite a lot of them are coming from China, and they're very susceptible to RF. And the last thing you want is to have your common mode current on the feed line. And if you run open wire feed line at the top, that means you have no choke at the feed line. And so the common mode current that's produced there goes straight into the feed line and comes down the feed line all the way to the shack. So the environment today is a lot more dangerous for that sort of solution than it was 20, 30 years ago. I would not recommend it today, although in the field, if you're out in the field, you can do that. You know, if you go on a field day and there's nothing around, you can do it. But I don't see any need for that anymore because I ran open wire fed dipoles for 45 years, and I thought that was the best solution. But then once I perfected the OCFD, there's no way I would ever go back to that, because why use a matchbox if you don't have to?
Yep, absolutely right. Keith, I've got a question from you.
Yeah, it's a number of people have advised putting choke balance next to the rig to stop things creeping into the receiver. What's your opinion on that?
I always do it.
Right.
Okay, but here's the next thing. What I see people doing a lot of times is they're putting the same one-to-one guanella or choke balun that they would use at the antenna. That is not necessary, you know, because I showed you earlier. In fact, I'll hold it up now. I can hold it up now. You can see it. This guy, this is what I usually use for that, you know. Yeah, there. This Maxwell choke. The common mode current that you have in the shack is usually not that well. It is if you have that bad case I showed you with 58 watts. That's a different story. But normally it's just a small amount of common mode current, and this is sufficient for blocking it. You'll also notice that this can sometimes stop a lot of noise. Now, here's how I connect, and I've got a nice drawing, but I don't think I can find that very fast. One end of this thing has got the female, and the other end is the male. So the male is going into the shack, and the female accepts a coax from the antenna. So I put that right next to the house. I put a ground stake in the ground, and when I connect the coax from the antenna to the female, I connect that to ground. So when the common mode current is on the feed line, it's looking for a path to ground. And if nothing else, it's going to go through the radio to get back to ground. But at that point, it sees a high impedance going on into the shack and almost a dead short going to ground. So it takes the short to ground, and you don't get any RF into the shack.
Does that answer your question, Keith?
I think so, yeah. I do have a little bit of a problem with earthing, though, because the house is built on a bank of stones because it's on the back of a beach. And unfortunately, I had to put in an earth rod at 20 foot long to actually get to a decent conductive layer.
Yeah, well, I've moved probably 30 times in my life. And sometimes I was in houses and right at ground floor, and sometimes I was on the 4th or 5th floor, and there's no ground up there, and there's no way to get it, especially when you're renting. You know, you can't do anything. And oftentimes what I had to do was just lay a counterpoise. I seem to have the most problem on 15 meters and 40 meters. I don't know why. And so I would just take like a 10 meter long or 33 foot long piece of wire, connect it to the chassis. When I was using a matchbox connected to the chassis of the matchbox, just lay it along the floor, and that helped a lot in reducing it, you know. And that was before I knew and learned to use chokes. So I'm talking like 40 years ago.
Okay, thanks.
Yeah. So I mean but you know, choke where you can, but you can also use the ground of the house, but that's not the best thing either, because that just transfers the RF onto that so that your neighbors might love you. I don't know. It's I'm not an expert on grounding. You know, I'm an expert on trying things till I find something that works. Haben wir deutsche Fragen da? Mike, Adriana.
Nein, vielen Dank. Es war alles sehr eindrucksvoll. Aber wie auch beim letzten Mal müssen wir uns, glaube ich, noch ein zweites Mal zu Gemüte führen. Aber vielen Dank für den Vortrag. Thank you very much for the talk. It was excellent, and we enjoyed it quite a lot.
Gern geschehen. Danke auch.
Meanwhile,
back.
Question?
Yes, go ahead.
Can I have a question?
Yes, go on, Jeff. Yeah, go on.
Yeah, good evening, Rick. Thank you
Hi.
very much. It was brilliant. I really learned a lot. Just a simple question. This one-to-one Gunella, could I use that for a classic dipole or a vertical antenna? Would that be sufficient?
Absolutely. Well, actually, for a classic, you know, there's never a best answer to that, because it all depends on how it's mounted. If you're out in a field, there's nothing around it, a classic dipole is probably, you're okay just using this. But if you've got your antenna where there's a lot of houses around and stuff, and your RF can be reflecting around and all that, you have more common mode current, then it's very advisable to use the one-to-one Quinella.
Okay.
So, you know, in the field, I usually just hang a Maxwell on it, and at home I always hang the Quinella on it.
Okay.
And on the, you know, I can't navigate fast enough, but I have a inverted L antenna for 160 meters. It's off in the woods. You can't even see it. And it comes down, it feeds straight into a one-to-one Quinella.
Okay.
Yeah, I mean, it's absolutely, you can use that. So,
And just another question. In English literature, you sometimes see the term line insulator. Does
Yeah.
that mean the same, or is that something different?
they call these a line insulator.
Okay. Yeah.
You know, and Radio Works was selling some pretty good line insulators. They must have had a TG1, TG2, but when I started using TG3, not sure what that stood for. I guess no idea. But anyway, TG4. So I had 3 or 4 of each of those, and they're very good. They're as good as these, you know. But they don't compare to a Quinella. But in many cases, I mean, if you're using them, for instance, to stop noise in your receiver, they work just fine. But it's exactly the same thing as the Maxwell choke. Now,
Okay.
Maxwell, that was Walter Maxwell W2DU, and his was a little bit different. He used a whole bunch of little tiny ferrites, and I'm using in mine here longer ferrites, and he used just one kind. My choke that I have here, with Spiderbeam is selling these now in kit form or in a single, fully built. I use 2 different types of ferrites in there. One of them's better for the low frequencies, and one of them's better for the high frequencies. So it's really 2 chokes in one. And they're real easy to build. But some people say, hey, that's not a Maxwell. I mean, a purist will say, no, Maxwell, he used a bunch of little ones. This uses fewer larger ones. But effectively, it's a Maxwell, you know, and it's a line isolator. Same.
Okay. Thank you. Thank you very much, Rick.
Yeah.
Brilliant talk. Thank you.
You're welcome.
Learned a lot.
Thank you, Jeff. Okay, anyone else with a question to Rick before we call it a night on this part? Yes, go on, Phil.
Phil.
Yes, thanks, Rick. Fascinating. I've learned a lot from this presentation tonight. So how do you rate this in performance-wise? We've heard a lot about the theory and that. I mean, obviously, you've spent an awful lot of time on this. Compared, say, with the G5RV 80-meter dipole, it's a decent height.
I wouldn't use it, well, on 80 meters. Well, the G5RV is not optimum for 80. It was optimized for 20 meters. This is superior. I've had, keep in mind that, you know, I ran Spiderbeam for 9 years, and I was tech support. I don't anymore. I've been retired for 3 years, but, you know, with thousands of customers around the world and hundreds, well, in the meantime, there's 2,000 running my antennas. I get lots of feedback and telling me, like, you know, this is, and I don't know why it'd be quieter than a G5RV, but like an in-fed half wave, much quieter than in-fed half wave. I can explain why. That has to do with the common mode current. But the G5RV was really never a good multiband antenna. The VK6, no, VK6 BKW, I think was the call. That was a much better all-band antenna than the G5RV. And if they're mounted at the same height, they should probably be comparable.
Right.
But I prefer this because you hear a lot of times people are using tuners with their VK6 what's it, BKW or something like that.
It's
Anyway,
BKW,
yeah.
yeah.
And it
ZS6 BKW.
The thing was this: when those antennas were developed, we were using tube radios, and we had pi networks in our transmitters and amplifiers, and then we didn't care so much about a little bit of a mismatch. And our transistorized radios today are a bit more finicky, you know. And I like it. It kind of also would depend, because, you know, people talk about G5RV and VK6 BKW as if that was just one antenna, but, you know, most of the time people build them themselves. Who knows what they put in there for balance? And I think a lot might depend on the balun, whether they're noisy or not. You know, and if you get a bad balun and have common mode current on it, then you could get bad SWR and so forth. So, you know, you'll hear a lot of bad about the OCFD antenna, but the people have built them wrong. And that's why I spent so much time. I think if somebody had told me 12 years ago, you're going to need 6 years to sort this all out, I think I would have just left it, not even started.
Thank you.
Yeah, Rick, it's ZS6 BKW.
Okay, ZS6, yeah, boy.
Yeah,
Well,
that was the design.
I've got it perfectly described on the comments page for part 1 of my presentation. So if you follow that link, you can read all about it. But anyway, I fell in love with this antenna. I mean, it's so simple, you know. It's you saw how easy it is to build the balun. The only hard part is putting it into an enclosure. You just wind some wire. If you can count to 15, you can do it. Well, 17 on the 80 meter, you know. And you know, using your finger and toes, you can easily do that.
Yeah, and like Rick, I'm a great fan of the liquid to paint on these things.
Oh yeah.
I think it's fabulous stuff.
Well, actually, the only reason I switched to this stuff is they don't have the liquid stuff, liquids electrical tape here in our local do-it-yourself shop or botch-it-yourself shop. So, but in the States they did. They had the liquid electrical tape. So I always just bought it. They had this. This is a German make, probably Henkel, I guess. But anyway, this is called liquid rubber. So Flüssig Gummi. I can't read what this. Yeah, Flüssig Gummi. Yeah. So I can buy this locally. That's why I switched to this, because I had to order the other one and needed it in a hurry. So I ran down to the hardware store and got it. But it's great for coating things. It's just, once you've done that, you really can't get it off. You know, it's on there forever.
Yeah, that's the downside when something goes wrong and you want to, getting it off is not easy.
I wanted to show you guys something, and I forgot to hunt it out. I said I had an OCFD up for 9 years. I actually showed the balun earlier. I said that was the first dual core I had built on a piece of plexiglass, and I showed it. And I put that up for CQ Worldwide DX in 2011 for CW. I put it up like near the end of November, and it's going to stay up just for 2 weeks, and I was going to take it down again. And the thing, I did not insulate it. I didn't put any liquid electrical tape on it or anything. It ended up being up for 9 years. And you know, I took it down and it was all grubby and all that, but it still worked perfectly well, even though I had not done it. But I don't recommend doing that. I mean, you know, I was always going to take it down. But what happened was I had to work for about 15 minutes to get it above some tree branches. It was an evergreen. And after a couple of years, the tree had grown so much that the antenna was going right through the middle of the tree, and there was really no way to get it out of there. And, you know, so I didn't want to take it down. But what I said earlier, I didn't have enough room for 80 meters. Luckily, we had the, what's it called? The bark beetle. The bark beetle infected some of our trees, or got into them. Lumberjacks came and cleared out some trees, and I went up and I looked. I said, if you could take out one more tree, I could put an 80-meter dipole in there. And so they did. And so then I moved my antenna up the hill. What a difference it made. And I had both antennas up at the same time, one up the hill, one down the hill. The one near the house, it was on all bands, 1 or 2 S units louder on band noise. And the one up the house, up the hill, I mean, it didn't have any band noise. It was just quiet, you know. And then in addition, all of the DX stations seem to come in maybe 1 S unit louder and sometimes 2 S units louder. So I ended up with 3 or 4 S units signal to noise ratio improvement just from moving the antenna, well, away from the house, but also it's much higher than the house up there. The base of the pole, it's a 14-meter pole. The base of the pole is just above the height of the house. And when the antenna was down the hill, the top of the antenna was at the roof level of the house. So, but I live on a pretty steep hill. Nevertheless, if you can get the antennas away from the house, don't think you're helping yourself by gaining extra height from the house. Put them out in the yard as far away as you can go.
Okay, thank you, Rick. Good bit of advice there. Right, anyone got a final question before we say good night to Rick and thank him for coming back again? No, if not, Rick, can I say thank you very much on behalf of everyone. It's been brilliant. You've had a lot of views already on YouTube of your first presentation. We're getting some comments. I must keep checking the comments from people. People seem to be posting all the time on the YouTube channel comments for you. Richard Morgan just put up a comment 4 hours ago today. Yeah. Just wants to publicly thank you, Rick, for this presentation. Got a little bleary-eyed with these old eyes, but great job, old man. And other people. So when I see them, Richard Muller, thank you, Rick, for this very interesting talk, and especially the appropriate balance and chokes to use for best performance. Looking forward to part 2. So, you know, people are picking this up. V9ASN Les said, excellent. I can't wait for part 2. This is a great opportunity to publicly thank Rick for his tireless efforts in helping me understand and build the OCFD, countless emails and direct messages. So there you go, Rick. You know, obviously part of your 100 emails a day, but, you know, we're getting comments from people watching the video on YouTube, as I'm sure we will for this as well. So thank you. It's been brilliant.
Well, I've enjoyed helping. I've probably helped, without exaggerating, about 50 people build OCFD antennas. You know, I get all the time, let's say 1 a week or something like that. And you know, if I begin, well, the trouble is when you have 600 pages on your web pages on the internet, there's always somebody asking me something. But just because I seem to have learned a little bit about some of the antennas, especially through the spider beam work and the balance, and I've got information there, they seem to think I know everything about everything. And I'd say half the questions I answer with, I'm sorry, but I don't know. You know, I might know somebody that knows. In that case, I send them on to somebody else, but I don't know. Nobody knows everything, you know. So I've even had some discussions with, well, W8JI, and I'd say 19 out of 20 times he's right, but I was right once. So every now and then he doesn't have the right answer. So it's rare, though. Normally it all gets down to, you know, when you've been in the game for 60 years, I've been in 61 years. And other than the first year in the Army during the Vietnam War, I was always active. So that 1 year I was unable to get on the air, not one QSO, but otherwise the rest of the time, always active.
Rick, thank you very much. Can we show our appreciation to Rick in the normal way, everyone? Thank you.
Okay, well, it was my pleasure.
Rick. Thank
You're
you.
welcome. Very welcome.
Yeah, Rick, and also I'm going to say good night as well to the viewers on YouTube. Thank you very much indeed for staying with us and watching it. And you've been going out on live on YouTube as well, Rick, with people popping in and out and watching it. And I'm sure they're going to come back when we put the final version up there as well. So